Okay, let's just dive right into this explainer and, really demystify the whole black box of unsupervised machine learning specifically for product managers. If you're building AI-driven products, I guarantee you've heard the term, but understanding exactly how it works under the hood and, more importantly, when to actually deploy it, well, that's what separates the good PMs from the truly great ones. Today, we're going to break down the complete theory, look at some real-world examples, and hand you the strategic playbook you need to harness the raw power of unlabeled data. So let's start with a pretty wild story from 2018. Walmart suspected they had an employee theft problem, but they literally couldn't pinpoint when or where it was happening. I mean, they had absolute mountains of transaction data, but no clear target to predict. Enter unsupervised learning. The algorithm had absolutely no idea what it was looking for, but guess what? It found these hidden, highly suspicious behavioral clusters happening right during shift changes and manager handoffs. By just tweaking their schedules based on those completely newly discovered patterns, Walmart cut their losses by a whopping 23%. A standard supervised learning model would have totally failed here, because you literally can't predict a theft pattern when you don't even know what normal looks like yet. And that perfectly tees up our crucial framework, prediction versus discovery. As a PM, you absolutely have to internalize this difference. Supervised learning, it's all about labeled data predicting known outcomes, like showing it past purchases to predict future sales, right? Unsupervised learning, on the other hand, is pure discovery. It operates on raw, entirely unlabeled data to hunt down hidden structures, similarities, or relationships that we haven't even told it to look for. Think of it like this. Imagine putting together an IKEA couch. Supervised learning is having the instruction manual right there. You just follow the predefined steps to get to a known result. But unsupervised learning, that's like totally tossing the manual out the window. It organically groups all the screws, the wooden pegs, the cushions, purely based on recognizing their physical patterns and shapes. It's building without a guide. All right, here's our roadmap for today. 1. Prediction versus data discovery. 2. Core unsupervised algorithms. 3. Real-world product use cases. 4. Measuring success and accuracy. And finally, 5. The AI PM's playbook. Let's hit section 1, prediction versus data discovery. So the most important thing to grasp here is that this type of learning is essentially an explorer. It digs into raw, chaotic data to spot groupings and relationships that are completely invisible to the human eye. There's no human sitting there on the front end telling the system, hey, this is right and this is wrong. It just organizes the data set based purely on underlying math. But, and this is a big but, while it saves a ton of human effort up front, it requires serious human interpretation on the back end to actually translate those mathematical groupings into something that makes real business sense. This brings us to a vital gut check question you should be constantly asking yourself as an AI PM. Are we trying to predict an outcome, or are we trying to discover a structure? If you want to forecast churn or catch spam, yeah, grab a supervised prediction model. But if you're trying to segment your users into entirely new behavioral groups you didn't even know existed, or maybe figure out why certain seemingly unrelated items are always returned together, that's exactly when you need an unsupervised discovery approach. Moving on to section 2, core unsupervised learning algorithms. We can essentially categorize the heavy lifting here into what I like to call the rule of 3. First up, clustering. That's grouping similar data points together. Think customer segmentation using algorithms like k-means or dbScan. Second is association. This is all about finding relationships between items. Market basket analysis is a classic example. Customers who bought X also bought Y. And third, dimensionality reduction. This uses methods like principal component analysis, or PCA, to take massive, insanely complex datasets and simplify them down so they can actually be visualized and processed without losing their core value. To make this concrete, let's walk through the actual pipeline of an unsupervised task, like categorizing a mountain of customer support tickets. It's a really clear flow. It kicks off with the initial clustering of the text, then extracts label candidates, does some part of speech tagging, word stemming, and finally, it requires manual adjustment. So what does this tell us? It proves that while the machine is amazing at grouping tickets based on hidden similarities, it absolutely still relies on a human, usually you, the PM, to validate if those clusters actually translate into a useful product feature. All right, on to section 3, real-world product use cases. Let's look at how an unsupervised anomaly detection algorithm, specifically the isolation forest, actually works in practice to identify outliers. Imagine a map of data points. The algorithm literally isolates the weird data, the points way out on the fringes away from the normal, dense clusters. In the banking and finance world, those isolated points represent fraudulent transactions. And the crazy part? The system does this without a single human ever explicitly telling it what fraud is supposed to look like. It just learns what normal is and flags absolutely anything that deviates from it. Now, for the technical PMs tuning in, peeking at the underlying code really shows how these anomaly scores are calculated across a feature matrix. The key takeaway here is that the code doesn't rely on an is fraudulent label. Instead, it fits the isolation forest directly to the data and calculates a decision function to rank transactions by how anomalous they are. Knowing your data scientists can rank anomalies like this is a total game changer. It means you can build features that immediately serve up the most suspicious cases to your human reviewers first, which drastically speeds up operational workflows. Next up, Section 4, Measuring Success and Accuracy. So, how do you actually evaluate your data scientists' work when traditional accuracy is completely off the table? Because remember, we have no ground truth to check against. Instead, we have to measure cluster cohesion, basically how tight the points in a single cluster are, and cluster separation, or how distinct the clusters are from each other. Think of this as your cheat sheet for sprint reviews. A silhouette score closer to 1 is great. It means clusters are dense and well separated. For the Davies-Bolden index, you actually want a lower score for better partitioning, and for the Kalinsky-Herbos index, higher is better. Keep these in your back pocket. Finally, Section 5. The AI PM's Playbook. Let's tie it all together. If you want to really succeed in this space, you need to master 5 key competencies. 1, problem mapping, making sure you aren't just jamming AI into a product for the sake of it. 2, data literacy. You have to be able to ask tough questions about the raw data. 3, managing uncertainty. These products are probabilistic, and honestly, 80% of the real work happens after you launch version 1. 4, explainability. That's how you build trust with your stakeholders. And 5, rigorous exceptions criteria. You have to monitor for things like data drift because peering into the black box of these systems is notoriously difficult. You also carry a massive ethical responsibility here to address biases and skewed information right at the source. Look, if your unsupervised model is clustering users or scoring anomalies, garbage data will 100% produce garbage results. And that can lead to some really unfair, unintended consequences for your users. You have to actively partner with your engineering team to add constraints, tweak objective functions, or use adversarial training to stop your models from just blindly mirroring and scaling bad patterns that happen to be buried in the raw data. So before you go and commit a massive budget to a hugely expensive data labeling operation, stop and ask yourself, what exact pattern are we trying to find? And do we actually need labels to find it? Simple, unsupervised clustering can so often organically reveal exactly what you need to build that next killer feature, or even help you define the predictive targets for a future supervised model. I'm going to leave you with this final provocative thought as you look at those mountains of messy, unlabeled data sitting inside your own company right now. Your data has a story to tell. Are you going to dictate the narrative, or are you going to let the data speak for itself? Unsupervised learning is an absolutely incredible tool for discovery. Use it wisely, evaluate it rigorously, and let those hidden patterns drive your product strategy. Thanks for hanging out with me for this explainer, and keep building great things.